Hi, my name is Mollie Stein. I am a backend engineer at Giant Machines, and I am here today to talk about my developer experience and how we use Postman to work better amongst ourselves, to work more efficiently, and also to give a case study on how we use mock servers. So to give some context, who are we at Giant Machines? We are a boutique consulting firm. We are located in the financial district of New York City. We build custom web applications for our clients. Some projects are fully front end, most are full stack. Our clients range from many different industries. So we work with banks, we work with financial institutions, we've worked with pharmaceutical companies as well as tech startups. So our backend team builds RESTful APIs for clients. Our teams typically range from 2 people up to 10. My current project is 10 people, and that's our largest one to date. And our engagements typically last anywhere from 2 months to a year. So we are big fans of Postman at Giant Machines. Our culture is deeply collaborative. We like to work a lot amongst ourselves, but also we consider our clients to be partners. So we like to work alongside with our clients. So today, I'm going to be focused on 2 things. I'm going to talk about the different ways that we use Postman as a team, give some examples. I always think it's pretty cool to see what other people are doing. And even amongst our teams at Giant Machines, it's always pretty exciting to see what other features that other teams are using. And then also, I'm going to provide a case study on mock servers. We found a pretty cool way to use them when we are blocked locally by external dependencies. So first, the main thing we do is create a team workspace for each project. So each project has a team workspace that contains collections, and each collection has our documentation at the time. So we have one collection for the API that we're working on, and we also have a collection for each external dependency. We also use the scripts extensively, so we can use pre-request and test scripts to save variables into each environment. And this allows us to effectively use collection runners. So here's an example of what our team workspace might look like. So at the beginning of each project, I like to create an environment for each of our deployed stages in addition to the local environment. And so this helps us to work a little bit faster because in order to test each environment, all we're doing is switching in Postman between each environment. So here we have local, dev, QA, staging, and production. Those are our typical stages. And here's what our workspace might look like. So on the left, we have the collections. The first collection is always the API that we are working on. And then we also have other collections for external dependencies. So typically, we'll have an authorization service, such as Okta or Auth0. If there's a payment service, we might have a separate collection. So Stripe is an example of a common payment service that we use. In this example, this is an e-commerce application. So we also have a shipping service. So in this first request here, I have create order. I also like to have each folder within a collection represent a user flow. So in this folder, this is an ordering flow. And the first endpoint is create order. And this provides easy documentation for all of us to share. So we have 10 engineers working on my current project. And it just helps us so much to have one source of truth. So we are building applications pretty quickly. Most of the time, we are starting from scratch. And it can take some time for our APIs to get to a stable state. So these collections are great. We can update them as needed. So This shows, what the request body looks like, what the response body looks like, and also any headers or params that might be required. And having this here cuts down significantly on the back and forth between developers. So, as an API developer, I know exactly what I want my request body and response body to look like, but, maybe the front-end engineers aren't so clear on, what I want them to look like. So this is an easy way to say, hey, this is where it is. We don't need to discuss it because the examples are right here. So we use the test scripts quite a bit. So the test scripts are super useful for saving variables. So in this request here, we are creating an order, and the response will have an order ID. So using the test scripts, we can save the order ID into the environment, so we don't have to copy paste that order ID into future requests. Somehow, copy pasting is one of the harder parts of being a developer. So we can also set up tests. We can check the status codes, and that will be useful for collection runners. We've also used the pre-request scripts, not as often as the test scripts, but they are super useful for setting authorization headers. So if we need to fetch a bearer token or a basic auth token, we can use the pre-request scripts to set them. And here's an example of what a collection runner might look like. I find these collection runners to be super useful. So I use them as I am developing, as I'm iterating through a feature to make sure that I'm not accidentally causing any regressions and making sure that the API is working as I expect it to. So typically, we don't have dedicated QA resources until the end of a project. So it is super helpful to have something like this available where I can quickly check the health of our API. So in addition to using this for local development, we can use this to quickly run through the collection runners as we deploy to each stage. So as we move from dev to QA to staging to production, we can do a quick check of the API without worrying about what's going on the front-end application. And then we also like to use the auto-generated docs that Postman provides. This has been super useful. So we can see in one page, all of the requests and everything that they require. Something that I learned yesterday is that saved examples in the request will actually flow through to the documentation here. So the front-end devs have been a big fan of using this because you get everything in one place as opposed to flipping through tabs. So I find that this works really well in conjunction with our Swagger docs. So we are a consulting firm. It is really important that we document well because we know that at the end of every project, we will be taking our API and passing it on to our client. So the Postman collections provide a super practical documentation for our clients. So typically what I do is I export the collections as a link and can easily pass that on to our clients that way because they are not going to be in our team workspace. Something that's been pretty cool with handoffs lately is finding out what other companies know about Postman. So on one project, the clients had not heard of Postman before, and I was able to help facilitate setting them up with their own Postman team account. On another project, the developers were also big fans of Postman, and they were super excited to see that we already had these collections set up. That was the first thing that they would have done too. So it's been really easy to provide a lot of value to our clients this way. The Postman collections are also a great way to help onboard new engineers. Our teams are often in flux, so depending on the needs at the time, we tend to add engineers on as we go. So it's super important that we're able to onboard engineers super fast. And with the collections, new engineers are able to start testing it out, getting familiar with the API way faster than just looking at the code base. So finally, I want to talk about mock servers. So we found this pretty cool use case for mock servers. So as I said, we work with clients, and it's really important that we don't have any developer downtime, that we are able to work quickly through any issues that may come up. So anywhere, all these things that we've been doing, it helps to save time, and that passes on as cost savings to our clients. So on most projects I've worked on, we've always had an issue with an external dependency. So, what do these mock servers do? They give us mocked responses that we want intentionally. So most APIs these days don't exist in a vacuum. A big part of backend development is integrating with other services. But calls to external servers are completely out of our control. Many things can go wrong. Servers can go down. They can return 503, service unavailable. The external database is also out of our control. It can become out of sync with our database within our API. And some data is short-lived, and that may be how it's supposed to be. And sometimes you just don't know what's going on, and it's completely out of your control. So one project I worked on was with an airline company. And on that project, we needed test booking data. So bookings would only last for about 48 hours. And we needed to work against that feature so that we could keep going. But the data would only last for 48 hours. So what we were able to do was create a mock server of that airline's API so that we didn't have to wait and ask for more test bookings. So that was super useful. On another project, on an e-commerce application I worked on, we were deeply coupled with a shipping service, and that shipping service dev environment was pretty unstable. It would constantly go down. They would wipe their database more frequently than us, and so we constantly were having problems with it. On the project that I am on now, security is super important, and when we connect to that other API, we are connecting through a proxy. And sometimes that fails. It always seems to fail right before a demo. So it's been really helpful for us to have a mock server of that API. So why exactly is this so problematic? Developers are blocked. That's downtime, kind of wasteful. So I'm going to go through an example of how we were able to use this mock server to continue local development. So this is this e-commerce application again, where we have an ordering flow. And this application is deeply coupled with the shipping service. So for every request that's made to our API, we are probably making another request to the shipping service, because we are maintaining a cart on our side. We also have to maintain a cart with the shipping service so that they know what they need to eventually ship. So in this example, let's say that we are trying to add a product to a cart. So what would happen is we would try to make this request to our API, and we would get a generic 400 bad request shipping error. So when you get this kind of error message, there's really only two possibilities. Either there's something wrong with our request, or there's something wrong on their end with their server. So by staying organized with the collections, I can just go over to my shipping collection and see what happens if I hit that endpoint directly, so not through my API, and see what happens. So if I hit that endpoint directly on the shipping service and I see 503, service unavailable, I know the problem is on their end, not ours. So our solution has been to configure a mock server for that external dependency. So I had one collection that maintained all of the endpoints for that shipping service, and I can configure the mock server using the local environment. And I'm going to stress now that this is really just for local development, just for making sure developers can keep working. So if I configure my mock server, I then get an additional collection that will maintain the mock server for that shipping service. So when you create a mock server, you get this additional collection as well as an additional environment that will give you the mock server URL. And the way that mock servers work is that the mock server will return saved responses from that collection. So I have this endpoint here to hit the shipping service directly. The endpoint is carts/cart123/ship, right? And I have a saved response from when it was working. So the reason why this works so well is because the Postman mock servers are so flexible. They work with a matching algorithm, so when you hit that endpoint, it doesn't have to match exactly, it just kind of needs to look like it and have the same HTTP verb. So if I were to hit the mock server with a cart ID different from cart123, as long as it looks kind of similar, it should go through. So when you are actually hitting that endpoint through your own API, you're probably generating new IDs, things are changing, but this is flexible enough that it should work. So if you pass through cart 456, it should still work. And the way that we actually embed this into our own APIs is by creating an additional configuration. So this configuration should be a duplicate of the local configuration, except the shipping base URL will point to the Postman mock server instead of the actual shipping URL. And what I really like about this is that it decouples my code base from this mock server. So I'm not shipping any code that includes any references to the mock. So I don't have to have mock data within my code. I just have this additional configuration. And so going back to our own API, so next time I boot up my server, instead of using the local configuration, I'm going to instead use the mock configuration. So when I hit that same endpoint again, so add this product to this cart for this order, my API will not be hitting the shipping service that is currently not working. Instead, it will hit the mock server. And then my API is able to use that mocked response to keep going. And this is super helpful when I'm working on a feature that's completely unrelated to the shipping service. So when you're unfortunately deeply coupled with another service, you can't just rip it out while it's not working. So we found this to be super helpful, and I'm good to go. So what are the benefits of this? There's, I think, a lot. It saves developer hours. It's easy to manage. We are managing this mock server in the same place that we are managing all of our other collections. And it also has minimal impact on our code base. We don't have mocked responses within the code. We just have this additional configuration. So thank you. If you have any questions, please come find me.